Now that the real heat is here, you're probably already living it. The air conditioning running almost all day, the unit outside roaring away, and the house still never quite comfortable. And at the end of the month, the electricity bill lands and you put your head in your hands. The usual response is to buy a more powerful unit, or just give up and leave it running around the clock, paying whatever it takes. That's the mistake almost everybody makes, fighting the heat with brute force and money, when the coldest, most stable, cheapest air conditioner you own has been waiting for you your whole life, right under your feet, and it's free. In Japan, and in any architecture that works with the climate instead of fighting it, this principle has been used for a very long time, with homes that cool themselves using the earth rather than a machine. It's nothing new. Japan's traditional thick-walled earthen storehouses, the kura, stayed cool inside through the peak of summer thanks to that huge mass of clay insulating them from the outside heat, and modern Japanese passive houses use what are called cool tubes, buried pipes that draw in air already chilled by the ground. It's the same old principle, just applied with simple plumbing. The core idea isn't to manufacture cold. The cold already exists. It's down there, in the soil of your yard, all summer long. An air conditioner burns electricity to create cold out of nothing. The smart approach is to stop manufacturing it and start borrowing the cold the earth is already giving you for free. And the famous cool loop, the buried loop, is nothing more than the pipe that connects your living room to that underground cold. It all starts with one single idea, the idea that holds up the rest of this video. Here's the fact almost nobody knows, and it changes everything. While in the peak of August, the surface of your yard can hit 95 degrees or more, the soil a couple of meters down stays cool and stable all year round, in many regions somewhere between about 50 and 65 degrees Fahrenheit, depending on where you live. It barely rises in summer or drops in winter because the ground is an enormous thermal battery. It has so much mass that the surface heat waves barely ruffle it. Think about that. Under your lawn, you have free and permanent, a reserve of coolness more stable than any appliance you could buy. It's the same reason a cave or an underground cellar is cool in the peak of August and mild in January, with no machine at all. It isn't that they're refrigerated, it's that they're surrounded by earth, and the earth at that depth doesn't even notice the seasons. Your yard hides exactly that same natural cellar. You just haven't connected it to your house yet. The air conditioner fights the heat by spending energy to invent that cold. The earth already has it. The Japanese approach isn't about manufacturing cold with a compressor and an electricity bill. It's about connecting your house to that cold reserve already under your feet and letting physics do the work. You don't fight the heat. You give your house an exit toward the cold that already exists. And once you understand that, you stop thinking about bigger machines and you start thinking about simple plumbing. Here's how it's done, step by step. The first step is understanding why this actually works, because everything else depends on it. Depth. The earth isn't cold at just any depth. In the top few inches, the soil heats up with the sun and tracks the air temperature. So up there, it's nearly as hot as the surface. But as you go down, the swings get damped out. At around 3 feet, you barely feel the difference between day and night anymore, and at a couple of meters, the temperature settles near your region's annual average and stays cool all summer. That's why the loop has to be buried below that hot surface layer, not near the top. The mistake that ruins half of these projects is digging a shallow trench. If you leave the pipe too high, the soil around it is as hot as the air and it cools nothing. The rule is simple. The further below that overheated surface layer you go, the colder and steadier your system runs. Digging deep isn't fussiness. It's what separates a working system from a useless pipe. And if you're already finding this useful, hit subscribe, because what's coming next is where the real difference gets made. The second step is understanding what that cool loop actually is and why it costs so little. It's, quite literally, a closed loop of pipe buried in the yard and filled with water. The key word is closed. The same water circulates around and around without being used up. It leaves your house carrying the heat from your rooms, runs through the buried pipe, and along the way that heat transfers into the cool earth surrounding the pipe, so the water comes back into the house several degrees colder than it left. Over and over. For the pipe, you can use the polyethylene or irrigation tubing used in plumbing, or even heavy-duty hose, which is cheap and sold by the foot. That's the secret behind the $60. The loop material costs little, and the rest of the parts, as you'll see in a moment, can be bought second-hand or salvaged. There's no compressor, no refrigerant gas, nothing expensive or delicate. It's water going around a buried pipe. The usual mistake is coming up short on pipe or burying it too shallow. The longer the loop and the more contact it has with the cool earth, the more heat it can dump. So length and depth are what decide the result. A trick to fit a lot of pipe into a small yard without digging to the center of the earth is to lay the tubing in horizontal trenches, snaking it back and forth, or in a loose spiral within the same long trench, so plenty of pipe fits in a reasonable dig. Just don't pile it tight on top of itself. If the runs of pipe touch, they heat each other up and you lose efficiency. You have to give them spacing so each run touches fresh earth. The third step is the part inside the house, the one that turns that cold water into cool air. And here's the clever bit that makes it almost free to build. You need three things: a heat exchanger, a pump, and a fan. The heat exchanger is simply something the cold water passes through that has a lot of surface area to release that cold into the air. The most typical and cheapest is a second-hand car radiator, a car heater core, or an oil cooler, which cost next to nothing at a scrapyard and are built for exactly this, to exchange temperature between a liquid and the air. The pump, small and low power, is what pushes the loop water through that radiator, and the fan blows the room's air through the cold radiator, so the air comes out the other side several degrees cooler and spreads through the room. And here's the magic of the savings. A small pump and a fan together draw a few dozen watts, compared to the hundreds or thousands of watts an air conditioner's compressor gulps down. You're moving water and air, which is dirt cheap, instead of compressing gas, which is what sends the bill through the roof. In fact, because the draw is so low, some people run the pump and fan off a small solar panel, so the system cools hardest exactly when the sun is strongest, which is when the panel produces most, and the grid electricity cost drops to nearly zero. By the way, all of this is part of one bigger system. If you want the complete Japanese method, with all the secrets for a home that's cooler, more comfortable and cheaper to run, the book is linked in the description of this video and on the channel. It's there if you want it. Moving on. The fourth step is what separates a toy from a system that genuinely cools, and it's pure, honest engineering: length, depth, moisture, and rest. We've already seen you need enough pipe and enough depth. Add to that a factor almost nobody considers: soil moisture. Damp earth conducts heat far better than dry earth, so a loop buried in moist soil sheds its heat much more easily than one in dry, dusty ground. If your soil is dry, burying the loop at a depth where the ground keeps some moisture makes a huge difference. And there's a fourth factor, the most ignored one: letting the ground recover. When the water dumps heat into the earth, the soil right around the pipe slowly warms up. If the loop is too short for the load you're asking of it, that soil saturates with heat and the system loses strength. That's why two things help: a generous loop with plenty of margin and giving it hours of rest, for example, using it mainly in the afternoon and evening and letting the ground cool back down during part of the day. A well-sized system with room to breathe stays cool all summer. A small, overworked one wears out. The fifth step is multiplying the effect without spending more. And here it's worth being honest about what this system does well and what it doesn't. The loop cools, but it barely dries the air. Unlike an air conditioner, which pulls out a lot of humidity, this system lowers the temperature but leaves the humidity almost untouched. So in very humid climates, it feels less cooling, and you'll want to pair it with something that dehumidifies. Also, because the radiator inside is cold, it's going to sweat, just like a glass of cold water sweats in summer. That means you have to put a tray or a drain underneath to catch that condensation so it doesn't soak anything or grow mold. And the most cost-effective point of all, this loop performs far better if your house isn't fighting a losing battle against the sun. If you also shade the windows from outside, ventilate at night, and stop the sun from heating the house during the day, exactly what we covered in the Sleeping Cool video. The loop only has to maintain the coolness, not rescue an oven. Each one reinforces the other. And now, right before the most important part of all, the one that makes this project genuinely worthwhile instead of a letdown. If you still haven't subscribed, this is the moment, because this is what most people get wrong and what decides whether the system changes your summer or not. And it's this. Don't try to cool the whole house with a $60 loop. That's the expectation mistake that leaves people frustrated. A cheap, homemade system like this isn't going to freeze an entire house in the middle of a heat wave, and promising that would be a lie. Where this system genuinely shines is cooling the room you're actually in, the bedroom at night, the living room in the afternoon, the office where you work. Concentrate all that free cold into a single space, the one you actually use, and there you'll notice a clear difference, several degrees cooler, with a ridiculous power draw. And used that way, as cooling for the space you occupy, is when it truly lets you switch the air conditioning off for much of the day instead of leaving it roaring non-stop. The smart play isn't to brute force cool the whole house. It's to take almost all the work away from the AC by properly cooling the spot where you are. That's the real, honest win. Now, for the fully honest part, because this channel doesn't sell fairy tales. First, this does not replace a big air conditioner in an extreme climate. It's a low-cost, low-power system that cools modestly but very cheaply, ideal for taking a few degrees off a room and drastically cutting your AC use, not for chilling a mansion to 70 degrees in August. Second, how much it cools depends heavily on your ground, on how deep you dig, on the length of the loop, on soil moisture, and on your climate. The same length of pipe gives a great result in one place and a weak one in another. Third, it barely removes humidity, so in humid areas it's a supplement, not a standalone solution. And fourth, the $60 assumes you're reusing cheap or scrapyard parts and that you're supplying the labor by digging yourself. With new materials, or if you pay someone to excavate, the bill climbs. All that said, under the right conditions, it cuts your air conditioning use enormously, and that's the real, honest promise of this method. And here comes the most important part of all, the safety part, and on this project, it isn't optional. It's a matter of life and death, so listen with full attention. Before you drive a single shovel into the ground, you have to find out what's buried in your yard. Underground run gas lines, electrical cables, water pipes and telecom lines, and rupturing one of them with a shovel or a digger can cause an explosion, an electrocution, or a flood and kill you. In many countries, there's a free service you call before you dig that sends someone to mark where those lines run. In the United States, for example, you call 811. Find the equivalent service in your country or region, call it, and don't put a shovel in until they've marked your ground. This isn't a suggestion, it's rule number 1 and it has no exceptions. Second point, electricity and water don't mix. Use pumps and fans made for outdoor use, with proper protection and GFCI outlets, and keep every electrical connection dry and away from the water. Third, if you dig deep trenches, watch out for collapses and for overexertion in the heat, and for big excavations, consider professional help. Fourth, keep the circuit always closed and the water always moving, with no stagnant, lukewarm water sitting around, and manage the indoor condensation so you don't get mold. And fifth, check whether you need a permit in your area before doing any major digging. Respect all this and the project is safe. Skip it and you're truly gambling with your life. And it's worth being clear about why the whole philosophy here is to borrow the cold rather than manufacture it, because it isn't only about the bill. A conventional air conditioner burns a lot of energy, heats up the street by dumping your home's heat outside, makes noise, and breaks down. Tapping the Earth's stable temperature gets you coolness for a fraction of the power, with almost no noise, no refrigerant gas, and a system with barely any parts to fail. Cool air isn't the goal in itself. It's the sign that you've stopped fighting physics and started using it in your favor. Borrow the cold, don't manufacture it. So here, specifically, is what to do this weekend, starting with what costs nothing and is mandatory. The very first thing, before anything else, call the buried line location service and wait for them to mark the ground. Don't pick up the shovel until then. While you wait, plan the route of the loop and gather the cheap parts: the polyethylene pipe or hose, a scrapyard car radiator, a small low-power pump, and a fan. Once the ground is marked and clear, dig the trench as deep as you can below the hot surface layer, lay the loop, and cover it, ideally with soil that holds some moisture. Inside the house, connect the pump, the radiator, and the fan, fill the circuit with water and bleed the air, and test it. When you fill it, let the pump push the water around for a while so all the bubbles work out, because a trapped air pocket stalls the flow and the system underperforms. And in areas where the ground can freeze in winter, it's worth adding a share of non-toxic antifreeze to the water so the loop doesn't burst in the cold. Start by cooling a single room, the one you use most. You start with what's free and safe, you move up to the second-hand parts, and you build your system in one weekend. And if you want the rest of the Japanese home methods at this same level of detail, they're all in the book in the description. So, to pull it all together, because the complete system is simple to remember. The cold already exists, stable and free, a couple of meters under your yard. A closed loop of buried pipe, long enough and deep enough, carries your home's heat into that cool earth. A scrapyard radiator with a fan turns that cold water into cool air inside the house. A tiny pump moves it all for pennies. And the winning play is to concentrate that coolness in the room you occupy, not the whole house. You stop paying to manufacture cold, and you start borrowing the cold the earth already gives you. And with that, you don't just cool the house for one day. You get a cool room all summer for pennies a day, with the air conditioning switched off most of the time and no shocks on the bill. And here's the best part, and the hook for the next video. That same buried loop that cools you in summer can flip the script in winter. Because when it's genuinely cold outside, the earth at that depth is warmer than the outdoor air, so the same system can help take the chill off your house when the cold arrives. In the next video, you'll see how the Japanese method uses that same earth to warm you for free in winter. See you in the next one.